Hi everyone, let's continue to talk about secant method. So how does this work? Suppose the interval AB has been located which is known to contain a 0. Since the function changed signs between A and B, we know there is a 0, right? So start with those 2 points, A and B, f of A, okay? F of B. So we denote it as x0, y0, x1, y1. Then the approximate solution is the value of x, where the straight line through the initial points crosses the x-axis. So this is very similar to what we did before for the regular Fossey method. Okay, we also talk about the secant line passing through the 2 points, and we find the x-intercept. Okay, and this is the x-intercept. Do you remember what we had before? We have like s equals b minus a over yb minus ya times yb. And here we just call x1 be b, x0 be a, y1 be yb, y0 be ya. So this is just, they're the same, right, everybody? Okay. Next, at the k stage, the new approximation is xk plus 1 equals xk minus xk minus xk minus 1 over yk minus 1 times yk. Okay, so let me draw the picture here. Then you will understand the difference between the regular Fossey method and the secant method. Okay, so for the regular Fossey method, let me use the orange color. Okay, so here I have so this is regular Fossey method. Okay, so A is here, B is there, and let's say this is f of A, this is f of B. Let's say our f look like this. So far so good, everybody. And on the other side, let me use green color for the secant method. And okay, A here, B here, f of A, f of B, and then we like this. So far so good, everybody. Are they the same? Let me see. I'm trying to make them look the same. Okay, so this is f, right? First step, we take the secant line passing through the 2 endpoints, and this is our s. So far so good, everybody. And on the other side, the secant method, well, we call A to be x1, we call B to be x2. We call A to be x0, and we call B to be x1. And then we draw the line connecting those 2 points, and we call this x1. So far so good. So the first step, you will see the values is going to be the same. Okay, because we're using the same line to cross the x-axis. Let's look at the second step. Well, second step, well, this is f of s. It's negative. Then we pick the right subinterval, right? And then we draw the let me see. We draw the line connecting those 2 points. Okay, and then this is our new s. Okay, our new s. And here we have this is f of x. This is still negative. And on the other side, here this is negative. Then we draw here. Okay. And for the secant method, we don't need to decide which subinterval. We use x0 and x1 to give us x2, and then we use x2 and x1 to give us x3. Okay? So this is f of x3. And then we use x2 and x3 to give us x4. So the next step, we look at these 2 points. And let me change a different color because this is the step to make them different. Okay, so we look at the secant line passing those 2 points. So this is x4. So far so good, everybody. And on the left, we still have we pick this subinterval, and then we construct the line, and this is our new S. You see? So the foci method, make sure each time we make sure our subinterval contains the 0. Okay, but however, our secant method, we have a list of the xi's. Okay, the previous 2 xi's can help us to generate the next xi. So the secant method doesn't bracket the zeros. Okay, so you look at this. It happens that x2 and x3, 0 is not in there. So far, so good, everybody. Yeah, and then when we continue, what happened? So we find this point, and then we continue here. And then on the right hand side, so we got this point, right? And then we look at x3, x4. That will give us x5. So we connect the points x3, x4. This is x5. Okay? So you can see here the 0. So first you look at x0, x1, and then you look at x1, x2, and then you look at x2, x3. You see the 0. So 0 does not lie in x2, x3. Okay. But when we continue to do more steps, you can see 0 lies in x3, x4, and the 0 lies in x4, x5. Okay? So note, advantage. This process does not require any testing to determine the action to take at the next steps. Okay, this is the advantage because unlike the bisection method and the regular foci method, every time we need to test, okay, are the endpoint positive or negative? So we need to decide which is the subinterval to continue that process. But here, secant method, we don't need to do that. Okay, the previous 2 points give us the next points. We just use the formula. Okay, so it's simply forming the next approximation from the previous 2 points. Yeah, and it also converges more rapidly than the regular foci methods in general. If it converges, then it converges faster. Okay, but the problem is we don't guarantee convergence for the secant method. Okay, yeah, so disadvantage. 0 is not required to lie within the interval at each stage. So we don't guarantee convergence for secant method. So far, so good, everybody. Alright, so let's do an example. Okay, it's the same function. Yeah, you might say, why do we do the same function again? Because the good thing to do the same function, then we can compare each method. Alright, we can compare different method and which one converge faster. Right? So, for secant method, we don't need to draw the interval. Okay, because we don't need to determine the value and we don't need to decide which subinterval to continue. There's no such thing. So, what do? Just draw the table. And so we have the steps, and then we do xk minus 1, xk, yk minus 1, yk, and then we have xk plus 1. So xk plus 1, what is that? Well, that's xk minus xk minus xk minus 1, yk minus yk minus 1 times yk. So far, so good. And at the end, we have yk plus 1. Okay, let's start. Step 1, we have 1 and 2, right? Yk minus 1, so when we plug in 1, 1q minus 2 is minus 1. Yk is 2q minus 2, which is 6. So far, so good, everybody? Okay, xk plus 1. xk is 2. So 2 minus 1 on top. And then yk 6 minus negative 1 times 6. So what is that? Well, where's our calculator? Right here. Okay, so 2 minus 1 is 6. 2 minus 1 is 1 times 6 is 6. And then divided by 6 plus 1, so 7. Yeah, actually it's the same thing as we had in the previous example using the regular Fossey method. Okay, so this is 1.14286. Okay, and yk plus 1 is just that number cube. Okay, so see, here we can copy again. If you have your calculator, just go up in the previous lines and then enter. Okay, so the answer is minus 0.50729. Is it? Yeah, let me see. Yes, we run up, right? Okay. Next step. Okay, next step we're gonna shift because my xk minus 1 is gonna be 2, right? And my xk is gonna be 1.14286. While my yk minus 1, it shifts. It's gonna be 6. So yk becomes this new point minus 0.50729. So far, so good? Alright. And then xk is 1.14286 minus 1.14286 minus 2 over yk negative 0.50729 minus 6 times yk. Oh, negative 0.50729. And what is that? Okay, now let's plug in our calculator. Where should I put here? Okay, let me put it here. 1.14286 minus. Can you see that this minus and minus cancel? So you see this minus and this minus cancel. We can think about this just plus, right? So it's just plus, and then the top we have 1.14286 minus 2 and divided by the bottom. Oh, bottom, because they're both negative, the bottom is actually negative 6.50729. You can also type minus 0.50729 minus 6. It's the same thing, but sometimes if I can calculate it, then I don't need to type more, okay? To reduce my work. Okay, so the answer is, let me see here. Oh, let me check my answer. Oh, I forgot to multiply by 0.50729. Yes. Okay, so now do I have everything? Good. So the answer is 1.20968. So 1.20968. Okay, then the yk plus 1 is this number cube minus 2. So copy and paste here. Negative 0.22984. So far, so good, everybody. Okay, next step. We're gonna shift this guy here, 1.14286, and then here is gonna be 1.20968. Here, shift it here, minus 50729. YK is negative 0.22984. Because we are working with a lot of numbers, we have to be very, very careful. Organize the data, okay? XK 1.20968, and it's enough to keep 5 decimal places. So you keep 5 decimal places in all of your homework and exams. Okay? So XK 1.20968. XK minus 1.14286. YK negative 0.22984 minus negative become plus 0.50729. YK is negative, so negative 0.22984. I almost ran out of space. Okay. So let me use this line. And you can see this negative and this negative gate sort of cancel. And let's plug in our calculator. Okay, where's my calculator? Here. Okay, so let's type 1.20968. And the bad thing about the secant method is every time you do need to type it again, because unlike secant method, every time you just find some spots, you're gonna change it. But for the secant method, we have to change a lot of numbers. Almost everything is different. All numbers are different because we shifted it. Okay, so we need to retype it again. Cannot be lazy. 1.20968 minus 1.14286 divided by negative 0.22984 plus 0.50729, and then times 0.22984. Okay, yes, and our answer 1.26503. 1.26503. And then that guy cube minus 2. So copy here. We can copy and paste. 0.024446. Oh, if we count 5 decimal places, it's then 0.02445. We round up. So far, so good, everybody. Okay, let's do one more step and we're done. So we shift 1.20968, and here is 1.26503, and here is shift 0.22984. Here is 0.02445. XK is 1.26503. XK 1.26503 minus 1.20968. YK 0.02445 minus negative become plus 0.22984 times yk. 0.24, oh, I missed a 0. Be careful, be careful about the 0. 0.02445. Okay. That's approximately equals, oh my 9 so ugly. Okay. Calculator here. Okay, so we're gonna type it again. 1.26503 minus parentheses 1.26503 minus 1.20968 divided by, okay, this is 0.02445 plus 0.22984 times 0.2445. Okay, so we get 1.25971 up 1, okay? 1.25971. 1.25971. Ooh, okay. At the end, this guy cube minus 2. So we can copy it here and paste here, enter. Oh, quite small. Negative 0.00101. Negative 0.00101. Quite small. So far, so good, everybody. Okay, so what is our estimated 0? So estimated 0 is 1.25971. Okay, so this is the estimate 0 after 4 iteration. So in your homework or exam, I will tell you how many steps that you need to do. Okay, so if we type this in MATLAB, and this is what we get. And you can see the 4 steps. We get 1.2597 and that match. And here 0.001 match as well. See? It matched with our answer. And this is the picture, right? So see? Here, this is around 1.25971 close. So far, so good, everybody. And the secant method also converges in the 6 steps. Okay, how do we use MATLAB to compute? Okay, so here, so the syntax is xxy bracket xxyy, and we have secants. Then we also input the function, the a and b of the interval, the tolerance, and the k-max. Okay, the maximum numbers of iteration. Okay, so let's look at this example. How about let's compute our in-class example first. All right, and so the syntax is, do you see here? Oh, I really hope that you can see it. So, okay, the syntax is xxyy equals secant, and we have the inline function. This is x cubed minus 2 from 1 to 2. Oops, 1, 2 with tolerance. Let's do 0.00001. Let's do 10 steps. Oh, okay. So you see in our 4 steps, we get 1.25971 in that match. And let's see here. Okay, yes, and this is close enough. Maybe it used more. Let me see. Do I? Oh, okay. maybe it used more digits, so the YK is a little bit different. Oh, because it has more digits, and throughout our calculation, we only do use 5 decimal places. So far, so good, everybody. Okay, so let's continue. Okay. So we have this example, right? Let's type this example in our MATLAB or Octave. Okay, so because we already type it, so we can just go up and find that line and change our function to be x to the 5th minus 0.5. And our interval is from 0 to 1. Okay, and enter. All right, now let's see what happened. Okay, see, the secant method converge in the 8 steps. Let's see here. Yeah, in 8 steps. With our the estimated 0 is 0.87055, and our YY is negative 3.2437 times 10 to the negative 6. Okay, so this guy means, yeah, E minus 06 means this number times 10 to the negative 6. That's the notation of the MATLAB. Okay, note. The secant method does not bracket the 0 at each iteration. It does not guarantee to converge. However, when it does, then the convergence is usually more rapid than for the either bisection method or regular Fosse method. Okay, so facts. Secant method does not guarantee convergence. However, when it does, the order of convergence is P. P equals 1 plus square root of 5 over 2. This is approximately equals 1.62. Do you still remember the regular Fosse method? The order of convergence is 1. We have linear convergence. And here, the order is 1.62. So a bigger number means it converges faster if they both converge, okay? And with the rate of convergence lambda equals the absolute value of f prime prime, so second derivative of f as a true value over 2 times first derivative of f as a true value. And then this guy to the power of b, where b equals square root of 5 minus 1 over 2. So in our class, we're not gonna prove it, okay? Just keep in mind that the order of convergence is around 1.62, which is bigger than the order of convergence of the regular Fosse method. Okay, so if they both converge, then secant method converge faster. Okay, but the problem is if we don't know whether they both converge, well, then we know the Fosse method always converges, but the secant method might converge or it might not converge. Okay. So here is the convergence theorem for the secant method. So we have the 3 conditions, okay? First, if f prime, and f prime prime, so the first derivative and the second derivative are continuous for all x in the neighborhood of near the true value, okay? Second, well, the derivative at the true value is not 0. See? Because look at our rate of convergence. We want our rate of convergence is small. Like small is like very small numbers, at least smaller than 1, right? So, but this guy, the first derivative is in the denominator. Well, you don't want to have 0 in the denominator, right? So that's why we require the derivative as 0 at the true value is not 0. Okay, and 3, the initial estimate x0 and x1 are sufficiently close to the true value. Okay, then the secant method will converge. So we have to satisfy those 3 conditions. The secant method will converge. So far, so good, everybody. Okay, So right now we have learned 3 methods so far. So our goal of this chapter is to solve nonlinear equations, right? Find the roots, find the zeros of a nonlinear function. Okay, so we talk about the bisection method. Bisection method, we don't really care the shape of the function, right? We just have an interval. Each time we separate into 2 equal subinterval, and then we look at which subinterval contains the zeros, and then we divide it into half again, and again, right? This is bisection method. We have an error bound. The error bound for the kth iteration equals b minus a over 2 to the power of k. Okay, so this is the error bound. And then for the regular Fosse method, what we do is we construct the secant line passing through the 2 points, and then we find the x-intercept of the secant line. Okay, that is gonna be our estimated zero. Alright, but then we have to decide which subinterval to consider in the next steps. So to pick the be the endpoint of the secant line. Okay, and because each step we also bracket the zero, so we guarantee convergence, and the order of convergence is 1. Okay, and then the secant method, we don't need to decide the subinterval. We just use the previous 2 points to construct the next point. Right? The formula of secant method and regular Fosse method is very, very similar. Okay, but just the choice of the points is gonna be different. Okay, and the secant method does not bracket the zero, so we don't guarantee convergence. But if it converges, then the order of convergence is it's close to 1.62, which is bigger than 1, so it converges faster than the regular Fosse method and bisection method. Okay, so at the end of this chapter, so we will learn more methods. We will learn Newton's method and some iterative method. But at the end of this chapter, I will make a summary of all those methods in comparison charts. So you will see the difference between the different methods. Okay? So have a nice day, and don't forget to do your homework. If you have questions, feel free to print screen and email me. And don't forget to do the MATLAB homework as well, or Octave. You can always check your work. I mean, for some kind of problems, right? If I just ask you to compute the estimated zeros. Okay, have a nice day. Bye.